Good morning, students. Today I would like to discuss you about Internet of Things. So before moving into what is Internet of Things, I would like to explain what is an IoT device first. So an IoT device is a device with the embedded sensors, actuators, software and network connectivity which enables it to communicate with the other device such that the two devices share and exchange the information. So once again I repeat, IoT device is a device with embedded sensors, actuators, software and network technology which enables them to communicate with each other and exchange the information. So every IoT device should have the main important electronic device which is nothing but a sensor. First one, sensor or actuator. Software. Third one is connectivity technology or network. So now Internet of Things is defined as a network of all the IoT devices such that they communicate with each other and exchange the information. So again I'm explaining, Internet of Things is a network of IoT devices. So whereas an IoT device is a device which has sensors or actuators embedded in them, or we can externally interface with the IoT device, and it should also have the software in it, and it also have some connectivity technology. So now I will explain each and every block in detail. So coming to the sensors. So first one is sensor or actuators. Sensor is an electronic device which detects a change in the physical environment and converts that change into an electrical signal. So sensor is an electronic device which detects a change in the physical environment and converts that change into the electrical signal. So what can a change that can be detected in the environment? It can be a motion of a object, or it can be a temperature change, or it can be a humidity. So this sensor, whatever might be the change in the environment it occurs, it detects that change and converts it into an electrical signal. So there are so many sensors we'll be using in our IoT system, like temperature sensor, so second one, motion sensor, third one, chemical and gas sensor, fourth one, proximity sensor, etc. So coming to the first one, temperature sensor. As the name itself indicates, it detects the temperature. So temperature sensor is a sensor which detects a temperature change in the environment and converts that temperature change into an electrical signal. So the best example is, suppose in my house I am using a smart temperature sensor. So that temperature sensor will be detecting the room temperature or your living room temperature and converts that room temperature change into an electrical signal. So coming to the second sensor, motion sensor. As the name itself indicates, motion sensor is a sensor which detects the presence or absence of a moving object and converts that motion into an electrical signal. So coming to the third one, chemical and gas sensors. So these chemical and gas sensors are used to measure the air quality. So gas sensors and chemical sensors are not separate. Gas sensors are a part of chemical sensors. Like chemical sensors are the sensors which are used to detect the presence of toxic or hazardous chemicals in the substance, which that substance can be either in a chemical form or a liquid form or a gaseous form. Whereas the gas sensors are the sensors which are used to detect the presence of a harmful chemical or a hazardous gas only in the gaseous form only. So these sensors are mainly used to measure the air quality in an environment. So coming to the last one, proximity sensors. Proximity sensors are used to detect the presence or absence of an object which is not moving. So whereas the motion sensor detects the presence or absence of an object which is moving. So whereas this proximity sensors are used to detect the presence and absence of an object which is a still object. So these sensors are used in our cars. So you might have known, suppose when we are making a back turn of your car, so if any object is present beside our car, it will make some beep sound. So that beep sound is mainly because of that proximity sensor. It alerts us that some obstacle is beside our car. So this is about the sensors. So next, coming to the actuators. So whatever the job does by sensor, the opposite job is does by the actuator. Sensors, what it will do, it will measure the, or it will detect the change in the environmental conditions and converts that change into an electrical signal. Whereas, so this actuator will converts the electrical signal into a physical motion. That means it takes input at the electrical signal, and the output it causes some motion like turning, or turning in the sense turning, closing or opening a valve, or simply making a motor turn either in the clockwise direction or in the anti-clockwise direction. So like the sensors we have discussed now, so there are so many actuators we use in our IoT system, like electric actuators, electric, piezoelectric actuators, pneumatic actuators, etc. So first, coming to the electric actuators. So electric actuators are the devices which uses electrical energy and converts that electrical energy to cause some physical motion. So whereas coming to the next one, piezoelectric actuators. So these piezoelectric actuators will be using a special material known as a piezoelectric substance. So these piezoelectric substance like a quartz metal, so this has a special property that suppose when we apply some electrical signal to it, it produces vibrations as the output. Suppose I apply some vibrations into the piezoelectric substance, then it will produce an electrical signal as the output. So this is about the actuators. So now I have discussed sensors and the actuators. So what is the second one that every IoT system should possess, or every IoT device should possess? It should have some software in it. Software in the sense is nothing but the protocols. So here in this IoT system, the protocols or the communication protocols defines how the two devices talk to each other. Like, so in our IoT system, we use many high level protocols like MQTT, AMQP, DDDS, XMPP, etc. protocols we use. So I will cover all those protocols in details. Just for now, I'll give you just introduction about the communication protocols we use in our IoT system. Software or protocols. So the first important protocol we use in our IoT system is MQTT protocol. MQTT. message queuing, telemetry transport, next AMQP, advanced message queuing protocol, DDS, data distribution service, etc. So in my upcoming lectures, I will discuss in detail how these protocols helps the information to move from one device to other device. So coming to the last one, connectivity technology. So this connectivity technology tells how two IoT devices talk to each other, like how they are connected. So whether the two IoT devices are connected using a IP technology, or whether the two devices are connected using a non-IP technology. So non-IP technology in the sense, so suppose I will take a situation, one situation. Suppose in my home, I am using from Amazon Alexa, and I am having some smart devices, smart bulb and a smart thermostat, smart bulb and a smart thermostat. Suppose I purchased this smart bulb, this is from some Philips Hue company, and I purchased that smart thermostat which is some from some Samsung company, right? But what I am using here, I am using here Amazon Alexa. Suppose that Philips Hue company supports Bluetooth technology, and that smart thermometer which is from Samsung company, that supports a Zigbee technology. But my Amazon Alexa supports both Bluetooth, Zigbee and the Wi-Fi also. That means my Amazon Alexa will be having Bluetooth module, Zigbee module and also Wi-Fi module. Then how the communication takes place in the sense, my bulb is using Bluetooth technology, my thermostat is using Zigbee technology. So this Bluetooth, Zigbee are nothing but non-IP technologies. That means they are not related to internet. But even though it is a non-IP technology, so this non-IP technology can talk to my Amazon Alexa. Like suppose I have given a command from my mobile app to turn this smart bulb on. So that status, that means it is on. So that status will be first sent to my Amazon Alexa, like, so it is of a Bluetooth type. So that command, it will send as a Bluetooth signal. So that Bluetooth signal will be receiving my Amazon Alexa app, Amazon Alexa device. So in my Amazon Alexa device, so there will be a Bluetooth module and also a Zigbee module and an internet module also. So what my Amazon Alexa will do, my Amazon Alexa will immediately accept that Bluetooth signal and converts that Bluetooth signal into a Wi-Fi signal. So why? Because every IoT device, as the name itself indicates, Internet of Things. So whatever might be the technology, so whether it can be a non-IP technology like a Bluetooth or a Zigbee, or an IP technology like a Wi-Fi or a cellular communication or a satellite communication. So whatever might be, every IoT device should be connected to the internet. But this Zigbee cannot connect to the internet directly. So next, my smart device which is using a Bluetooth technology cannot directly connect to an internet. So now what my Amazon Alexa will do, it converts that Bluetooth or a Zigbee signal emitted by my smart thermostat into a Wi-Fi signal. So then this Amazon Alexa app will be paid up or will be connected to my router. So from the router, that command, what is the command it is giving? My bulb want to say to the cloud server that my bulb is on. From the mobile app, you opened it. So you open the corresponding bulb and you slide the option as bulb on. Then that bulb should also send the status to the cloud server. So then how it will send? So first it will send the status as bulb is on. So that signal is a Bluetooth signal. So that Bluetooth packet will be received by my Amazon Alexa. So Amazon Alexa converts that Bluetooth signal into a Wi-Fi signal. Next, my Amazon Alexa is connected to the router. So this Wi-Fi signal will be reaching my router. So from that router, it travels all the way along the cable to the internet service provider. Then that internet service provider will connect to the cloud server. So that cloud server is a cloud server which my manufacturer of the smart bulb, which is nothing but a Philips Hue company. Suppose that Philips Hue company took the subscription of Google Cloud. So then my internet service provider will send the status of the bulb to the Google Cloud server. So this is actually how the communication takes place in an IoT system. So now why all thing I explained is that, so that bulb is using a non-IP technology Bluetooth. My smart thermostat is using a non-IP technology Zigbee. So that means these two IoT devices are communicating with my Amazon Alexa. So this Amazon Alexa is also an IoT device. So non-IP technology communicating with a non-IP technology, in which it is again converted into an IP technology. So like that, suppose I have some smart device X and smart device Y in our house. So both the smart devices are having the internet modules there. So then there is no use for me again to put a separate device and convert that signal into another signal. Why? Because already those two smart devices are having internet modules, inbuilt internet modules. That means they are generating internet modules, in the sense Wi-Fi modules. So those two devices by default they are releasing a Wi-Fi signal. So there is no need for me to again take a device and convert that Wi-Fi signal again into a Wi-Fi signal. So immediately I'll pair up the two smart devices which are having the Wi-Fi module directly with the router. I hope you understood the difference. So in the first case, what I have to, in the first case, those two smart devices are using non-IP technologies. So using an Amazon Alexa app, I paired it up and I converted that non-IP signals into IP signals. So what I mean to say is, so this Amazon Alexa app acts as a gateway. So in the second case, as both the devices are having Wi-Fi modules inside, so there is no need for me to again buy a gateway and put it there. So the main purpose of gateway is to convert a non-IP signal into an IP signal. Clear? So next, coming to the connectivity technologies that I have explained now. Once I will write it. Connectivity technology. Connectivity technology. So just I have explained non-IP technology and IP technology. Non-IP technology means Bluetooth. That means one IoT device can be connected to the other IoT device using a Bluetooth technology or a Zigbee technology. Or my one IoT device can be connected to the other IoT device using a Wi-Fi or a cellular communication or a satellite communication. Clear? So if any system has all these elements which I have explained till now, so that network of systems is nothing but an IoT device. Clear? So next, coming to the characteristics of an IoT device. What characteristics should every IoT device have? So every IoT device should compulsorily possess 5 important characteristics. Those are: characteristics. First one, dynamic and self-adapting. So coming to the first characteristic that every IoT device should possess, dynamic and self-adapting. Every IoT device should dynamically react to the change in the environment and it itself adapt to the changing environment conditions. Every IoT device should dynamically adapt its conditions. Like, suppose, it would be better if I explain it with an example. Suppose I have took a surveillance system, smart surveillance system, in the sense it has many smart Wi-Fi cameras. So suppose it is a daytime. So in the daytime, it is not necessary that always a high resolution, I should put my camera in a high resolution mode. So then how the IoT device or the smart Wi-Fi camera should act? It should itself change its mode from high resolution mode to low resolution mode. And suppose it is a night day, and it itself should change from a day mode to night mode. So what this smart Wi-Fi camera it is doing? It is dynamically observing the changes in the environment, and it is itself adjusting its camera options. So every IoT device should dynamically observe the conditions happening outside, and it itself should adapt to the changing environment conditions. So your second one is self configuration. Self configuration. Every IoT device should be self configurable in the sense, so it should itself update the softwares without manual intervention. Suppose take in your mobile phone. So for every 1 days or 2 days, we will be getting a message in our phone like software updates are needed. Only if we accept it, then only the software updates will be done in our mobile. So if we don't accept, so it will be ignored. But this is not the case for the IoT device. So this IoT device should be itself update the softwares whenever it is needed. So coming to the third one, unique identity. Unique identity. So like every PC has a MAC address, so every IoT device has a unique identity address. So this address will make the IoT itself by itself join in the network. So with suppose in my home I have installed some smart device newly. So suppose when I upload the app corresponding to that company, so when you open the app, by itself your device will be detected in our mobile app. So this is mainly due to this unique identity property or the unique address of that smart bulb or that smart device. So next, coming to the fourth one, interoperable communication protocols. Interoperable communication protocols. So every IoT device, irrespective of the manufacturer company, they should be always be communicating with the other device. Like suppose I have installed in my house 4 smart devices: X company, Y company, Z company, and some W company. So irrespective of the companies, they should be always be able to communicate seamlessly. Next, last one, integration into the information network. Integration into the information network. So every IoT device should be easily integrated into the information network. Like suppose for this unique identity, what I have explained, every IoT device should be by itself should be shown on the mobile app, or it should be itself get registered into the existing home network. But here, and also coming into our existing, integrating into our home network, it should also be capable of integrating into a large database. Like suppose I'll take one example. So I installed a smart meter in our house. So it is of some X company. So that X company is somewhere. So it got tie up with some server database. So whatever the information sent by this smart meter, so should be always be stored in that X company's cloud server. So this should happen seamlessly. That means whatever might be the IoT device, so first it should get integrate into my home network, And also next, it should also integrate into that company's database which has purchased some X cloud server. Clear everybody? So this is about what is an IoT system and what are the elements should present in an IoT device such that they communicate with each other. So once I'll explain once again. So Internet of Things. So Internet of Things in the sense, so Internet of Things is a network of devices with embedded sensor or an actuators, software and the connectivity technology that such that they share the information and exchange the information. So coming to the sensors and the actuators. So the sensors are the electronic devices which detects the change in the environment and converts that change into an electrical signal. So these are the sensors we generally use. So temperature sensor is a sensor which converts the temperature change in the environment into an electrical signal. Motion sensor is the sensor which detects the presence or absence of a moving object and converts that movement into an electrical signal. Chemical and gas sensors are the sensors which are used to measure the air quality, and the proximity sensors are the sensors which are used to detect the presence or absence of an object which is not moving. So these sensors mainly converts the change into a electrical signal. So next, actuators. So actuators does the opposite job of sensors. Actuators converts the electrical signal to cause some physical motion like closing or opening a valve or turning a motor in the clockwise direction or in the anti-clockwise direction. So these are the actuators we generally use. So electric actuators are the actuators which uses electrical energy to cause a motion. So piezoelectric actuators are the actuators which takes the help of piezoelectric substances such that when an electrical signal is applied to it, it causes some vibrations. So that vibrations makes the motor to move either in the clockwise direction or in the anti-clockwise direction. So the pneumatic actuators. So the pneumatic actuators are the actuators which uses the compressed air to cause a motion. So this is about the actuators. So next, coming to the software part. Software part is nothing but a protocols. The protocols determines how the devices talk to each other. So these are the high level protocols we use in an IoT system like MQTT, AMQP and DDS. So in my upcoming lecture, I will explain in detail how these protocols work in an IoT system. So next, coming to the connectivity technology. So the two IoT devices can be connected either using an IP technology or a non-IP technology. So non-IP technology in the sense, so that a smart device can have a Bluetooth module or a Zigbee module in it, and an IP technology in the sense, so that smart device can have a Wi-Fi module, or it can also use a cellular communication technology like a 4G or a 5G to communicate with the other device, or simply it can take the help of a satellite to communicate with the other device. So these are the characteristics that every IoT device should possess. So what is the first characteristic? Dynamic and self-adapting. So dynamic and self-adapting in the sense, so every IoT device should observe the change in the environment and it itself should adapt to the changing environment conditions. So next, coming to the self-configuration. So every IoT device should by itself should update the software settings. Next, unique identity. So every IoT device, like for every PC we have the MAC address. So every IoT device will be having a unique identity such that using that unique identity, it itself get registered with the home network. And the interoperable communication protocols. So whatever might be the manufacturer company of the smart device, so all the devices should be able to communicate seamlessly. So integration into the information network. So every IoT device, along with the integration into our home network, it should also integrate into the company database. Like I have taken an example. Suppose a smart meter is of some X company. So that X company has purchased some Y company server. So along with the smart meter integrating into our home network, it should also send the data seamlessly to the cloud server database. So these are the characteristics of an IoT. So next, I would like to explain So how an IoT works? So the basic procedure or the practical procedure, how the data gets transferred from an IoT device to the cloud server. So next, how IoT works. So first step, data ingestion. So we already know the IoT devices have embedded sensors, or they can be interfaced externally also. So first one, data ingestion. So whatever the data collected from the sensors, so it can be with the sensors or it can be directly sent to the cloud server. So in the first step, data ingestion means data generation. So the data is mainly generated by the sensors. Next, second one, data transmission. Data transmission. So what I have explained in the previous step, so the data can be with sensors or it can be sent directly to the cloud server. If the data is with the sensor, that means the sensor is also having some memory chip inside it. Suppose that is only a sensor, in the sense it only generates a temperature reading. Suppose if I take a temperature sensor, it doesn't have a memory chip inside. So that data should be finally reach the cloud server. So this data can be sent using what I have explained in the previously. So the data can be transmitted. So the data can be transmitted using a IP technology or a non-IP technology. So next, data processing. So suppose here in this step, the data generated by the temperature sensor has reached the cloud server using either an IP technology or a non-IP technology. Next, data processing. So this is an important step. So this data processing is done by the back-end software which is present in the cloud server. Suppose in my house I am having a smart thermometer. So this smart thermometer will send the readings to the cloud server every 3 seconds, right? So for every 3 seconds, the whatever the data sent by the sensor, smart temperature sensor will be stored in the cloud server. Data processing in the sense, so generally cloud server don't know where the smart thermometer is. Smart thermometer also, temperature sensor also don't know where the cloud server is. So the data has to travel a long and long and a long distance, and it should then reach the cloud server. So in the meanwhile, the readings will get corrupted, or it will combine with some noise signal. So what my cloud server backend software will do, it will first filter the data. So this is the first basic processing operation which is done by the backend software which is present inside the cloud server. So data processing, cleaning, or data cleaning or filtering. Second step is removal of unwanted data. Removal of unwanted data. Suppose my temperature smart temperature sensor has sent a message that the temperature of the living room is 300 degrees centigrade. It is quietly impossible. Then what the backend software present at the cloud server will do? It will simply ignore the data. So removing of the unwanted data. So not only these two, the backend server present at the cloud server can do many data processing operations. So in this step, my data got filtered and it removed the unwanted samples. So now I am having a pure data with me. So in the next step, data visualization is done. Data visualization. So okay, the cloud server is having some data with it. Then how can the user know? So the user can be able to see the data sent by the cloud server using the mobile app. Suppose I have installed in my house a Philips Hue smart bulb. So immediately after the installation, what I will do? I will install the Philips Smart Hue app, and then I will pair up, and then directly or indirectly, so that Philips Hue smart bulb will be getting paired up to our router. So it got internet access, not direct. Why? Because that Philips Hue bulb will be having only a Bluetooth module in it. So again, what I will do? I will use some gateway. So this gateway or a device which converts a non-IP signal into an IP signal, that is, I will be using a Bluetooth to Wi-Fi converter device. So then I will connect that gateway to the router. From there and there it will go to ISP. That what I have explained in my previous slides. So data visualization. So whatever the data of the cloud server will be having, so that data should be visible to us. So that data can be made visible to the user either through a simple message like the temperature in your living room is 25 degrees centigrade, or it can be also represented using a bar graph, like suppose at 6 p.m. your temperature is 20 degrees centigrade. Again, at 7 p.m. your temperature is 21 degrees centigrade. So the data can be made visible to the user either using in the form of a bar graph charts, or it can be made visible to the user either through a simple messages. So next, so after data visualization, data analytics. Data analytics. Data analytics is a process of analyzing the data stored in the cloud server and drawing some meaningful conclusions from it. In the sense, I will explain it with an example. So this is data visualization. So at the end of the day, what it will give a statement like at 12 o'clock or at 1 p.m. your living room temperature is highest. How the cloud server came to know this? So how the cloud server came to know is this through this process, data analytics. So it analyzed the data for the complete whole day for the 24 hours. It took all the parameters from the backend software, took all the data which is stored in the cloud server. It made some operations on it using some data analytic tools that I will explain in my upcoming classes. So it has analyzed the data, and finally it has sent a message to the mobile user that at so and so time your temperature in the living room is highest. So that analysis part is nothing but data analytics. So in the next class I will explain deeply so what are the communication protocols we use. Thank you.